While designing a pharma clean room, heat load plays a very important role. Not knowing all the sources of heat generation in a clean room can mess up all your heat load calculation data and your overall design. And proceeding with this wrong set of data will result in designing the wrong air handling unit, and this wrong air handling unit won't be able to achieve the desired temperature or the parameters as per the regulation. Thus, while designing a pharma clean room, the pharma engineers must be aware of all the heat load sources in the concerned room. Hi, I'm Omkar Tilve, a clean room engineering coach, and in this video, you will learn the 8 major sources of heat load in a pharma clean room. Before we get into the sources of heat load, let me tell you what is a heat load. The heat load is the amount of heat energy generated in the clean room that tends to raise the temperature of the concerned room. Now, any equipment or anything which can raise the temperature of the clean room or add heat to the clean room is considered as a heat load of that clean room. So these heat load are classified into two sources, which are the internal sources and the external sources. So let us see the internal sources. Now, internal sources are the sources which are within the boundaries of the clean room or within the boundaries of the HVAC system which is catering to that clean room. The first internal source are the process equipments and the appliances. Now, let us see why. Heat is given out as a result of the function and operation of these equipments. Now, these equipments can be anything like the granulation machine, the weighing machine, the bottle filling machine, the bottle washing machine, any equipment which dissipates heat as a byproduct will add heat to the clean room, and so this needs to be taken into consideration as a heat load during the calculations. The second internal source are the people working in the clean room or the room occupancies. Now, what happens is heat is generated within the human body due to the process of metabolism. So, the number of people working in that particular clean room should also be taken into account while designing the heat load. So, the third internal source are the clean room lightings, because the electric bulbs in the clean room lightings also dissipate heat in the clean room, so this should also be accounted. The fourth internal source is the air blower or the fan in the air handling unit. Now there's a catch here. The heat gain from the blower is considered as an internal source if the blower is placed after the cooling coil in the AHU. Now the blower is a mechanical device and it runs and it is driven by an electric motor. Now this motor dissipates heat, and also due to some frictions in the rotor of the blower, due to some friction and vibration, there is also heat given out. So this heat should also be taken into account while designing the clean room. Let us move to the external sources. Now the first external source and very important and crucial external source is the solar exposed walls and roofs, because solar exposed walls and roofs absorb direct heat radiation of the sun, resulting in continuous heat addition to the clean room. What happens is one needs to be aware of which wall is exposed directly to the sun, as this wall will absorb the heat radiation from the sun and dissipate it in the room continuously. Also, the heat addition and the heat transfer through these walls depends on the direction in which the wall is facing, whether it is north, south, east, or west. So accordingly, this heat should also be taken into consideration. The second external source is the solar exposed view glasses. Now, you won't find much solar exposed view glasses in pharma clean rooms, but if it is there, what happens is as the glasses are transparent, the sun rays will directly enter the room and the radiation will be absorbed by the material and the air present in the room, and this will abruptly increase the temperature of the room. So this needs to be carefully taken care also. The third external source are the clean room partitions and view glasses. Now these are not the walls or the view glasses which are exposed to the sun, but these are the partitions which are being shared by another adjacent room which is not air conditioned. As the other room or the adjacent room is not air conditioned, the temperature in that room is atmospheric, which is much greater than the clean room. So there is a transfer of heat from that other room to the clean room. So this should also be accounted while doing the heat load calculations. Now let us see the fourth external source, which is the infiltration of air. Now what happens is, this is the ambient air entering through cracks and doors from outside the HVAC system. Due to the operations of the doors or some leakages in the wall panels, the atmospheric air will enter into the clean room, which will be at atmospheric temperature and will raise the temperature of the concerned room. Therefore, one needs to take care of the amount of air that will enter, and the heat addition due to this air should be taken care also. So these were the 8 major sources of heat load in a pharma clean room. If you found this information valuable, I would love to read your thoughts in the comment section below. This is Omkar signing off. Bye bye.